Alright, in this lesson now we're going to be now using our asymptotes to graph these rational functions by hand. So these are the key terms that we had done before, asymptote and rational function. We need to now get one other little key term, which are called holes on a rational function. Right, what's a hole of a rational function? It actually is a line, and on the line is actually an open circle on it, a hole on the graph, because it is undefined at that specific spot. So taking a look at these two examples here, if I wanted to find a hole, you're basically factoring your rational function. These are already factored, if you notice, because we have parentheses. So, what do you think would be the hole in this rational function? Hopefully everybody's noticing that these two are identical. And it makes sense because what happens if I make this a 1? It becomes a 0 down here. Same thing here. This is my hole. My hole specifically is at x equals 1. Okay, let's take a look at the second example. We have all these things on the top, all this on the bottom. What do you think the hole is on this graph if I was to graph it? Well, these two are the same, and these two are the same. So those are my two holes. So what specifically, where is it? It's at x equals what? Negative 2. And it's also at x equals negative 3. This might come into play when we start graphing these. Alright, so we're going to graph this one together. So in your book, we're going to be graphing 3 over x minus 2. I wrote down some steps. This is a good idea to put in your notes of how to graph this by hand. So we're going to be finding our asymptotes if there is a hole, and also finding y and x intercepts, because that's going to help us to reduce the possibilities on our graph. So let's find our y-intercept first. So our y-intercept is where the graph is crossing the y-axis, right? So I'm going to let x equal 0 in this equation. So I'm going to take my equation and I'm going to plug in 0 for the x. So this is going to give me 3 over negative 2, or negative 1.5. So the point that I would graph here is 0, negative 1.5. So I'm just going to keep it there until we start graphing it. We want to find our x-intercept. That's where it's crossing the x-axis. So all you need to do here is set the numerator equal to 0. So this is impossible. We don't have nothing here in the numerator to substitute to solve for that one. So there is no x-intercept. Alright, let's see why that is. Alright, now we need to find our asymptotes. Alright, let's find our vertical asymptotes. So a vertical asymptote is setting your denominator equal to 0 and solving it. So my vertical asymptote is x equals 2. Let's see, horizontal slash oblique. Okay, what is the degree of this bottom one here? It's 1. What is the degree of this numerator on the top? Now, I don't know if you remember what the degree of is of an integer. So, if the degree of the top and the degree of the bottom is bigger, that means the denominator, what? Has a bigger degree. That means it is y equals 0. So the horizontal asymptote is y equals 0. Are there any holes on this graph? Nope, nothing the same to cancel out, so there are no holes. Alright, so I have set up a chart here because we need to figure out now specific points, test points on this graph to be able to graph it completely. So it's going to kind of look like a piecewise function with pieces here, depending on like where we see our asymptotes. Alright, so let us actually sketch in the asymptotes first. So I am looking at x equals 2. So I'm on my x-axis. All right, let's pretend. Put a couple lines. Right here, x equals 2. This is my vertical asymptote. So I am sketching in my asymptote as a dotted line because it's getting real close to this graph, but it won't cross it. How would I sketch in this? What is y equals 0? Y equals 0, right? Here's y equals 0, is actually your x-axis. So we do have another asymptote right on the x-axis, so I'm just going to put a little dotted line right on the x-axis. So that means we have a graph on this side of this dotted line and also on this side of the dotted line. Now we have to determine if it's above this or below this. So we're going to be doing some test points here. So let us first go ahead and graph this y-intercept, 0, negative 1.5. So here's 0, negative 1.5, so that's about here. So to me right now, this is telling me that this graph is going to be going in this like area down here. It's not going to cross. So let's choose another number that is somewhere over here. Let's choose negative 1. So I have my negative 1, and I'm going to plug it in the equation. Oh, negative 1 minus 2. That's giving me 3 over negative 3, which is negative 1. So I would plot the negative 1 comma negative 1. Negative 1, negative 1. So, yep, this is not crossing this asymptote, right? Because that's what a graph does, doesn't cross it. And it's getting close to this other one. If for some reason our y-intercept was up in this area, then we would definitely know it's in over here graphing it. All right, let's take a look at now the right-hand side, past the 2 here. All right, let's choose 3. Let's plug in 3. 3 over 3 minus 2. 3 over 1. So that answer is 3. So I'm plotting 3 comma 3. 3 comma 3. So that's telling me that I got this point that the graph is in this area. It's getting close to that asymptote and to the other one. So here is the graph of 3 over x minus 2.